Hi everyone, Miss McCaslin here with another video for you. Today we're going to be learning about the phases of the moon as well as the seasons and how those two things are affected by the positioning of the sun, the moon, and the earth. You should have your note sheet with you that will take you through the PowerPoint that I'm going to show you today. What is the moon? The moon is actually a large rock that orbits our planet. The Earth only has one moon. Some planets have several moons, but ours is just one. Moon orbits planets, and then planets will orbit the sun. Some interesting facts about the moon. The moon is 240,000 miles away from planet Earth. That's a really long way. The moon rotates counterclockwise. That means it goes in the opposite direction that the hands on a clock would move, for those of you that were wondering. There are holes in the surface of the moon. These are called craters. They kind of make it look like it has a face sometimes at night. If you're taking care of filling out your moon log and looking up at the sky at night, you might see those craters smiling back down at you. And the moon actually gets its light from the reflection of the sun. And that's what we'll talk mostly about today. The sun, the earth, and the moon. You can see the positioning here. Here's our sun. Down here is the earth. And the moon is rotating around the earth. Why doesn't the moon look the same every night? You may notice that when you look up at the sky, the moon tends to change its shape a little bit. Well, the truth is, the moon never actually changes its shape. It just appears to look differently because of where it's positioned. As the moon orbits around the earth, the light from the sun is shining on it. This is happening all the time. But from Earth, we're only able to see very certain portions of the moon that's lit up because of where we're positioned. It takes the moon about 1 month, approximately 29 days, to completely orbit around the Earth. Throughout the month, the moon's position changes, and we can see only some parts of the illuminated moon. Let's look at an animation of this happening. Here you can see the Earth in the middle. This is the sun over here, and the moon, which will rotate around. This box on the left will show you what the moon looks like from Earth. So you can see here that when we started, the moon was directly in between the Earth and the sun. The sun is lighting up the far side of the moon, but the side that we can see is darkened. As the moon starts to rotate up, or revolve up around the Earth, you can see that the sun is still illuminating half of the moon. However, from Earth, over here, this is what we can see. This is called a waxing crescent moon, because it looks like a crescent. As the moon continues to move, you notice that half of it is still lit by the sun, because this is the half of the moon that is still facing the sun. Now from Earth, we're at a different angle. Now we can see half of the moon. This is called a first quarter moon. The moon will continue to go around the Earth, and as it does, you will see that 1/2 of the moon always remains lighted by the sun. The amount of that we are able to see depends upon how the moon is positioned in relationship to the Earth. When the moon is directly opposite the other side of the Earth, we see what is called a full moon, because we are able to see the full lighted side of the moon from the sun. The moon will continue to move eventually until it comes all the way back around again, and what we will experience is called a new moon, which is basically when the moon looks dark. Let's go back to our PowerPoint. The moon does cause our tides as well. This is another topic we'll be discussing. Ms. Schaefer's going to do a video about tides and eclipses, So I'm going to leave that to her. So we'll skip through this a little faster than I normally would. But you can take down these notes if you have these. I'm not really sure if I included those in the notes or not. But tides are caused by the gravitational pull of the moon. You will learn more about this as you do investigations and you watch Ms. Schaefer's video. There are two types of tides, high and low. And a high tide will occur twice a day. Here's some pictures that show you a high tide and a low tide. If you've ever been to the beach and been sitting there on your blanket or on your chair, and suddenly the water that was so far away in the beginning of the day is nipping at your toes, that's because it's moving, because high tide is moving in. It actually has to do with the positioning of the moon, believe it or not. Again, you'll learn more about that later. Here's another diagram of the moon phases. You can see the sun is always shining on the moon because the sun is not moving. The earth and the moon move. And because of the movement of those two bodies, we see different phases of the moon. We start off with the new moon. This is when the moon is lit by the sun, but the lit side of the moon cannot be seen from the earth whenever the moon is positioned between the sun and the earth. The moon appears black during the new moon phase. Waxing crescent. This is what you just saw in the animation a few minutes ago. The moon is lit by the sun. We can only see the small portion of the lit moon from the earth. This is called waxing crescent. Moving along, the moon continues to be lit by the sun. Now we're able to see half of what is lit from earth. As the moon continues to move, it appears as though it's growing. But what's actually happening is that it's moving into a position which allows us to see more of its lighted side. Until finally, the entire lit side of the moon is visible from Earth. This means that we are seeing a full moon. The moon continues to rotate or to revolve around the Earth until we come back to the new moon. These phases build upon one another. You can see here, this is new moon. It's dark. Some people might think the moon's not in the sky at this point, but it is. We just are not able to see it because it does not light itself. We need to be able to see the light that the sun is shining on it. You can see that it continues to grow until we are able to see the full lighted side of the moon, and then it will decrease again until we finally get back to the new moon. Looking at all the phases together, again, you can see, here's the new moon, waxing crescent. Waxing and waning are two vocabulary words that you have on your vocabulary list. Waxing is when the moon appears to be growing, and waning is when it appears to be decreasing. Waxing crescent, first quarter. Waxing gibbous, full moon. Waning gibbous, last quarter. Waning crescent, new moon. Sometimes first quarter and last quarter will also be called half moons. That's your notes on the moon phases. We will talk more about these as we go through our investigations and explore the relationship between the sun, the moon, and the earth. Now we'll move on to the tilt of the earth and how the tilt of the earth causes us to experience seasons. Day and night is something that we experience here on earth. What is tilting? Well, our earth is tilted on its axis at 23.5 degrees. The axis is that imaginary rod that runs right down through the middle of our planet. And you can see here that the earth is tilted at 23.5 degrees. Here's a 90-degree angle, and here from this point to this point is our 23.5 degrees. How does the earth move? Well, I'm glad you asked. It rotates. One complete turn on its axis. It does this every day. 24 hours it takes for it to make one turn. But it is also revolving at the same time. As it is rotating, it is also moving around the sun. It does one complete orbit of the earth, or the earth does one complete orbit around the sun. This takes approximately 365 1/4 days. This is equivalent to 1 year. So, Why do we have a leap year then? I'm sure you all know the answer to this question, but I'll help you out anyways. Because it takes 365 and 1/4 days for the Earth to revolve around the sun, every 4 years, those 1/4 days add up to one extra day, which is why every 4th year we have 366 days in a year. It's like those little fourths just get banked for a little while until they make up one complete day, and then we add it on. So because of this, we have what happened. Let's try that again. Because of this, we experience what's called day and night. As Earth rotates on its axis, it turns towards and away from the sun. Daytime is when our half of the Earth is facing the sun, and nighttime is when our half of Earth is facing away from the sun. Here you can see a diagram or a picture of the Earth. The half over here is faced away from the sun. Therefore, they're experiencing nighttime. This half is facing towards the sun and experiencing daylight. So, what does all this have to do with seasons? Well, it takes Earth 1 year to orbit around the sun. As the Earth orbits, it's tilted at different angles, either towards or away from the sun. Hopefully this is starting to ring some bells, because you should have learned this last year. Summer is warmer than winter, in both hemispheres, northern and southern, because the sun's rays hit the Earth at a more direct angle during summer than during the winter. Here's a diagram showing you northern hemisphere seasons. You'll notice the northern hemisphere, when it is tilted away from the Earth, or from the sun, the sun's rays hit it at not so much of a direct angle. They're going to be spread out wider across the top here. Since they have a wider angle of distribution, we're experiencing colder temperatures, or winter. Here you can see that because of how the Earth is tilted, this top northern hemisphere, the sun's rays are hitting at a slightly more direct angle, but still scattered a bit, so we experience the season of spring. Down here, the Earth has now moved to this side of the sun, and its tilt is now leaning towards the sun. Therefore, the sun's rays are hitting at a very direct angle, causing the northern hemisphere to experience summer at that time. And then finally, the Earth will revolve down to this part of the sun, where its tilt, notice the tilt has remained the same all 4 times. The tilt does not change. So now those rays are hitting again at a slightly more distributed angle, the same way we had with spring, which is why our spring and our fall temperatures are very similar. Here is a look at a year of seasons. Again, the middle, we have the sun, Big Mac Daddy guy. He doesn't move. He just stays put. But the Earth is revolving around the sun as it rotates as well. As it rotates, we have days and nights. As it revolves, we have seasons. Let's start with March, since that's where we are now. We should be experiencing spring at this point, but Mother Nature has other ideas. As you all know, it's been very cold lately. However, based on the positioning of the Earth and the tilt of its axis, we should be experiencing some moderate temperatures right now, because the sun's rays would be hitting our Earth at a somewhat varied angle. They're not going to be totally spread out, and they're not going to be direct. As we move along the months towards June and July, which we will still be in school because we've missed a lot of days, we will start to experience summer temperatures. Because if you notice, this northern hemisphere is directly in line with the sun's rays, causing warmer temperatures. We will then move into fall. Northern hemisphere again, moderate temperatures because of where it's located. And then down here in January, December timeframe, the northern hemisphere is pointed away from the sun, causing the sun's rays to be distributed out at a more wide angle and hence causing colder temperatures. That's your information on moon phases and seasons. If you have any more questions, please feel free to ask any of your teachers. And if you missed out on any of the notes, just go back and watch the video again.